Hello everyone, I'm Preeti Bodkhe, an intern at the Spark Foundation doing graduate rotational internship program in data science and business analytics from the batch September 2021. Today I'm going to present to you the first task of an internship, which is predicting the outcome using supervised machine learning algorithm. The problem statement given to us is to predict the percentage of a student based on the number of hours he or she had studied. Also, we need to predict the score for a student who had studied for 9.25 hours per day. In terms to predict the outcome asked, we'll be using simple linear regression algorithm, and the steps we have followed are: 1. Importing the required libraries. 2. Importing the data set. 3. Exploring and understanding the data. 4. Fitting the linear regression model by OLS method. 5. Plotting the best fit line. 6. Validating the relationship between X and Y variables. 7. Evaluating the model. And 8. Predictions. Now let's look into the solution. We need to import the libraries like pandas, seaborn, statmodels.formula.api, and matplotlib.pyplot. In step 2, we'll be importing the data by pd.read_csv function. We have got the standard scores data in CSV format. Now we will look at the data with the .head function, which will give us the first 5 observations of the data along with all the columns it has. Here we can see there are 2 columns in the data. One is hours, means the number of hours student is studying per day. And second is score, means the percentage or score that particular student has achieved. Looking at the observations or entries in the data, we can say that the student studying for 2.5 hours per day can achieve 21% of score, and the student who is studying for 5.1 hours per day can achieve around 47% of score, and so on. As per the problem statement, we need to predict the score for student on the basis of their study hours. Hence, our X, or you can say independent variable here, would be hours, and our Y, you can say dependent target variable, would be scores. Now let's understand and explore the data. So we have used .info function to get the detailed information about the data. And we have also visualized the data using distribution plot and scatter plot. So first we will check the detailed information, and looking at the information, we understand that there are 25 entries, means 25 rows in the data, along with 2 columns, and both the columns has no null values. Hence, we will not have to deal with any null values. The data type for hours column is float, and for score column is integer. Now we will check the correlation between both the columns by .cor function. The correlation value is coming as 0.98, which states that there is a strong correlation between both the variables, and it is very good for us to build the model to predict outcome asked. Now we will check the data distribution for each variable by seaborn.displot function. And also we will check the outliers in the data by box plot. So first we'll check the distribution of hours column, and we can say that there is normal distribution hours column or hours data has almost a normal distribution. Looking at the box plot of hours column, we can say there are no outliers in hours column. An outlier is an unusually large or small observation. Outlier can have a disproportionate effect on statistical results, and it may have a big effect on the slope of the regression line. Hence, it is very necessary for us to detect it and deal with it in case there are any outliers in the data. So let's check the distribution plot for scores. It also seems to be almost a normal distribution. Looking at the box plot of scores column, we can see there are no outliers in scores column as well. Now, let's check the scatter plot between both the variables. As we have discussed earlier, our independent variable here is hours and dependent variable here is scores. Hence, hours we have plotted on x-axis and scores we have plotted on y-axis. Looking at the graph, we can clearly say that there is a positive linear relationship between both the variables. Now, let's move ahead to the step 4, fitting the linear regression model by OLS method. Since we have only 2 variables in the data, we are using simple linear regression model here. And OLS method, which is nothing but the ordinary least square method, we will use to fit the model, providing y variable and x variable. We have used smf.ols function to fit the model, and we have printed the model summary also here. Model summary is giving us the value of r square, adjusted r square, then intercept values, t values, p values, skewness values, kurtosis values of the data distribution. Now let's plot the best fit line. Best fit line is nothing but a straight line drawn through the maximum number of points on a scatter plot, balancing about an equal number of points above and below the line. It is used to study the nature of relationship between 2 variables. So the line here in the graph we can see is the best representative line for all the data points determined by ordinary least square method. And we have plotted it with the function of Seaborn.ridge plot. Now, let's validate the relationship between x and y variable. So we have printed here the coefficients, or you can say model parameters, which is intercept of the models. And the value of intercept is coming 2.483673, and hours, this value is nothing but the beta 1 value is coming 9.775803. So I'll explain here about the parameters. As per the formula of linear regression, as we all know, y hat is equal to beta 0 plus beta 1 into x. Here we are getting the value of beta 0 as an intercept. So beta 0 as an intercept and beta 1 as hour. Hence the final formula to predict y means scores for any given value of x means study hours of a student becomes y hat is equal to 2.483673 plus 9.775803 into x. Now, the algorithm here is also checking the hypothesis test simultaneously. In every hypothesis test, we define 2 tests. One is null hypothesis and other is alternative hypothesis. So null hypothesis here says beta 1 is equal to 0. That means there is no influence of x variable on predicting y. And alternate hypothesis says beta 1 is not equal to 0. That means there is an influence of x variable on predicting y. If beta 1 is 0, then there wouldn't be any influence of x variable on predicting y. And hence, it is very necessary for us to check this hypothesis test simultaneously. In hypothesis test, we generally compare the p-value with alpha value. And if p-value becomes lesser than alpha value, we reject the null hypothesis. And if it comes greater than alpha value, we fail to reject the null hypothesis. So let's check what happens in this case. So now we have printed p-value and p-value for the model. Let's look at the p-value since we have to compare the p-value with alpha. And our p-value is coming 9.132624 into e raised to minus 17, which means it is almost 0. So looking at the p-value of a model, we can clearly say that it is less than alpha, and hence we can reject the null hypothesis here, which means there is an influence of x variable on predicting y. So since we have validated the relationship between x and y, and it looks good, we can now evaluate the model. So we are evaluating the model printing R squared value, and the R squared value is coming around 9.95. So looking at the R squared value, we can again say that the model is performing very good in predicting y variable. So as asked in the problem statement, let's predict the score for a student who's studying 9.25 hours per day, and it is coming as 92.90%. So looking at the prediction above, we can say that the predicted score for the student who had studied 9.25 hours per day is 92.90%. I hope you enjoyed this presentation. Thank you so much.